So this problem is asking us to determine if the function is telling us, if this information is giving us that we have a max, a min, or an inflection point, or none. And so now what comes to our mind immediately is that we're looking at a second derivative. The fact that this is a second derivative tells us we're not looking at maxes and mins, but we might have an inflection point. We might be looking at an inflection point. So how do we do this? Well, just having the values, we know that the second derivative values, we know that if this is equal to 0, then we know that these are all the potential places where we might have an inflection point. And so when we set this equal to 0 and solve, it's purposely done in a way that it's simple to see. It's already factored, so therefore we know this first factor set equal to 0, the second factor set equal to 0, the third factor set equal to 0. When we solve all of these, we would get x equals -8, x equals +1, and x equals -6. Now that is very useful because we can now put these onto a second derivative number line. There we go. Marking our zeros. And now we simply just need test values. We're going to sub in something to the left of -8. Maybe we'll sub in a value of -9 or -10, or you could always go with the ever so popular -1 billion, because when you sub that in, it makes it very easy to see the values. Now, the key to this is we don't care what the actual values are. We just need to know if they're positive, negative, and they can't be 0 because our zeros are already found. So just positive or negative. So when I sub in into this original function, I'm going to get myself a little bit of space so I can do that. There we go. So when I sub these values in, if I sub in -9, let's say -9 plus 8, -9 minus 1 cubed, -9 plus 6 to the 6th. All I'm going to pay attention to is, are they positive or negative? -9 plus 8 is a negative number. -9 minus 1 is a negative number to the 3rd. And -9 plus 6 is, again, a negative number to the 6th. Now, the powers are going to come into play. Now, a negative cubed, that's still negative. Negative to the 1st is still negative. Now, anything to an even degree will always, I apologize, that shouldn't be a 9. That should just be a negative number. There we go. Anything to an even degree is always positive, right? A negative times a negative is a positive number. So therefore, that's a positive. And this will never change. No matter what number we substitute in, this factor will always be a positive answer because of the degree of 6. So I'm going to look at this now and say negative times a negative times a positive makes a positive. And now we start over. But I'm not going to touch that last one because we already said that last one we know is always positive. So I don't care. This is just positive. All right, now we're going to pick something between -8 and -6, maybe -7. So here we go. -7 plus 8, -7 minus 1 cubed. -7 plus 8 became positive. -7 minus 1 is still negative cubed, and we're going to bring down our positive. So now we're looking at a positive times a negative times a positive, which would make a negative. And we continue on. Now, this particular problem was only asking us for -6. So I really just need what's happening around -6. So I didn't need that to the left of -8. I just need to know what's happening to the left of -6 and to the right of -6. So we got to keep going. You're going to pick something between -6 and 1. 0 is usually a popular option, especially when you don't erase your values. Okay, so if I sub in 0, that would be 8, positive number. -1, negative number, cubed. And once again, positive. Don't care, it's positive. So therefore, let me get this to a positive. There we go. Positive times a negative times a positive makes another negative. So therefore, what can we tell? Well, if we had negative concavity to the left and negative concavity to the right, that would mean we have nothing. There was not a change. So therefore, there was no inflection point. Now, so therefore, we could say at x equals -6, there was no inflection point. Now, just for sake of argument, even though this problem didn't ask for it, if we look at the value of -8, if we look here at -8, we look to the left, we see it's positive. We look to the right, we see it's negative. It changed. Doesn't matter if it goes positive, negative, or negative, positive. It changed. So we could say at x equals -8, we have an inflection point. And this is how we use the second derivative number line to determine inflection points.